What has 5 eyes, can see colors invisible to humans, and navigates with a built-in GPS? A bee. But what happens when this tiny, incredible creature makes a 1 in a million mistake and flies directly into your eye? The answer is both fascinating and terrifying, and it reveals a shocking link between the world's most important pollinator and our own precious sight. What has 5 eyes, can see colors invisible to humans, and navigates with a built-in GPS? A bee. But what happens when this tiny, incredible creature makes a 1 in a million mistake and flies directly into your eye? The answer is both fascinating and terrifying, and it reveals a shocking link between the world's most important pollinator and our own precious sight. So, you think a bee has 2 eyes, right? When you look at a bee, it's easy to notice its 2 large, dark eyes. But that's only part of a much more bizarre and complex visual system. A bee actually has a total of 5 eyes. The 2 big ones are called compound eyes, and they're marvels of natural engineering. Each one isn't a single eye, but a dense mosaic made of thousands of tiny individual lenses called ommatidia. A worker honeybee can have around 5,500 per eye. Each of these microscopic lenses grabs a single point of light, kind of like a pixel in a digital camera. The bee's brain then stitches these thousands of signals together to create a wide, panoramic picture of its surrounding. This gives the bee an incredibly wide field of view and makes it exceptionally good at detecting motion. In fact, bees perceive color and motion about 3 to 5 times faster than we can. To a bee, our world might just look like it's moving in slow motion. But the compound eyes are just the start. Arranged in a neat little triangle on top of the bee's head are 3 more, much smaller eyes called ocelli. These simple eyes don't see images or fine details. Instead, they are highly specialized light sensors that detect the overall brightness of the environment and help with flight stability and orientation. While the compound eyes are the primary tool for navigating by polarized light, the ocelli also contribute, particularly in dim light at dawn and dusk. Think of it as a biological GPS, hardwired right into its head. Perhaps the most mind-bending part of bee vision, though, is how they see color. Like us, bees are trichromatic, meaning their vision is based on 3 primary colors. But while ours are red, blue, and green, a bee's are blue, green, and ultraviolet. This means they aren't very sensitive to red. A vibrant field of red poppies wouldn't be a colorless void, but would likely appear as a dark, grayish, or black patch. In exchange, they get a true superpower, the ability to see ultraviolet UV light, a wavelength completely invisible to the human eye. This unlocks a hidden dimension. Many flowers that look plain to us are covered in intricate patterns in the UV spectrum. These patterns, known as nectar guides, act like glowing landing strips, pointing the bee directly to the flower's center where the pollen and nectar are. It's a secret language written in light. A simple yellow sunflower might have a vibrant, dark UV bullseye at its center, making it impossible to miss. So, we have a creature with 5 eyes, a wraparound view of the world, a built-in solar compass, and the ability to see a secret, luminous language painted across the landscape. It's an extraordinary visual system, perfectly designed for a life of flight and foraging. But this complex system, designed for finding flowers, can lead to a terrifying encounter when a bee's flight path intersects with our own. Suddenly, this marvel of nature becomes a medical emergency. The same biological tools that give a bee its superpowers become the instruments of a shocking and devastating injury. When nature's navigator becomes a nightmare, a bee sting is never pleasant. But a sting directly to the eye is an exceptionally rare and dangerous event. It's not just the puncture that's the problem, it's the venom. Bee venom is a complex and potent cocktail of toxins designed to cause pain and inflammation. In the protected environment of the eye, it can wreak havoc. The immediate symptoms are intense, excruciating pain, extreme light sensitivity, uncontrollable tearing, and severe, rapid swelling. But that's just the beginning. The stinger itself is barbed, designed to lodge in tissue, which means it's incredibly difficult to remove. If a piece of the stinger stays in the cornea, the eye's transparent outer layer, it can continue to leak venom, acting as a constant source of toxicity. The toxic and inflammatory reactions from the venom can lead to a cascade of devastating complications. One is severe damage to the cornea. The venom can trigger a reaction that destroys the crucial endothelial cells lining the cornea, which are responsible for keeping it clear. When they're damaged, the cornea can swell with fluid, become cloudy, and lead to permanently blurred vision. In a documented case, a 62-year-old man stung in the eye suffered this exact complication. Even with intensive treatment, his cornea didn't recover, and he ultimately needed a corneal transplant to restore his sight. But the damage can go much, much deeper. In the most terrifying cases, the venom can trigger something called central retinal artery occlusion, or CRAO. This is basically a stroke of the eye. The inflammatory compounds can cause a blood clot or vasospasm, blocking the main artery that supplies oxygen to the retina. When the retina is starved of oxygen, its light-sensing cells begin to die within minutes, and the damage is often irreversible. There is a reported case of a 66-year-old woman who was stung on her face, near her eye. Within 2 days, her vision had completely disappeared. Doctors diagnosed her with CRAO. Her vision was recorded as no light perception, meaning she couldn't even tell the difference between light and dark. Despite treatments, her sight in that eye was gone forever. And then there is the gravest risk of all, a catastrophic infection. A bee's stinger isn't sterile, and it can introduce aggressive bacteria deep into the eye. This can lead to a condition called endophthalmitis, a severe infection inside the eyeball. The eye can fill with pus as inflammation rages out of control, rapidly destroying the internal structures. In one horrifying case study, a 43-year-old man was stung in the eye. Within 48 hours, he developed signs of a severe infection. Doctors identified aggressive bacteria, including Pseudomonas aeruginosa, in his eye. The infection progressed so rapidly that it turned into panophthalmitis, an inflammation of all layers of the eye, and began to spread. His vision was lost completely, and to stop the infection from spreading and save his life, doctors had no choice but to perform an evisceration, a surgical procedure to remove the entire contents of his eyeball. From corneal scarring and cataracts to glaucoma and optic nerve inflammation, the list of potential complications from a single bee sting to the eye is long and terrifying. It's a stark reminder of the incredible power packed into tiny creatures. If you learned something new and want to explore more amazing and sometimes shocking stories from the natural world, be sure to subscribe and hit that notification bell. And let us know in the comments, have you ever had a close encounter with a bee? The connection between bees and our eyes is a story of shocking contrasts. On one hand, we have a creature whose visual system is a masterpiece of evolution, a five-eyed navigator that sees a hidden world of light and patterns we can only imagine. This extraordinary vision is essential to their role as the world's most important pollinators, a role our own survival depends on. On the other hand, a chance encounter, a one-in-a-million accident, can turn this symbol of nature's ingenuity into an instrument of devastating trauma. The very same creature whose eyes are built to navigate the world of flowers can, with its venom, inflict irreversible damage on our own organs of sight, causing everything from corneal damage to retinal strokes and even the complete loss of an eye. It's a powerful lesson in the delicate balance of our world. It teaches us to have a profound respect for these vital insects, to appreciate the incredible, complex biology that allows them to thrive, while also understanding the potent danger they can carry. The bee is both a creator of life and, in the rarest of circumstances, a harbinger of darkness.